Hello everyone, welcome to the Learn Extra Maths revision. Today we're going to take a look at grade 12 Analytical Geometry. So we'll be preparing you for the upcoming exams. So we're looking at Analytical Geometry today. But before we jump into the questions that I've taken from past papers to help you practice, I'd like us to take a look at the list of things that you should know in order for you to be able to tackle questions on analytical geometry. Firstly, and very importantly, is that you need to know the distance formula. So you must be able to recognize, first of all, and apply the distance formula. Okay, so recognize and apply the distance formula. This you'll find on your formula sheet. So it's not too much of a train smash if you forget it. Secondly, you need to be able to recognize and apply the midpoint formula. This you should also find on your formula sheet. Thirdly, be able to calculate the gradient or slope of a straight line. Now this you learned long ago in the lower grades, gradient of a line, of a straight line. You also need to know the relationships between parallel and perpendicular lines. Again, from grade 9, you must know how those two are related. And also be able to calculate the inclination of a straight line. So you need to know what an inclination is of a straight line and hence calculate it. Be able to find the equation of a circle with a center at the origin and center at another point, not 0, 0. Another point, we'll call it AB in general. Lastly, be able to recall the properties of quadrilaterals, circles, and tangents to a circle. Right, so now that you know what we need to know for our exams, let's jump into the questions. Here's question 1, which was taken from a February 2013 paper 2, question 4. So in the diagram below, trapezium ABCD with AB parallel to BC is drawn. So firstly, it's a trapezium. And they tell us which two sides are parallel. It is BD, I beg your pardon, it's BC, parallel to AD. There it's indicated by means of arrows. The coordinates of the vertices are A, 1, 7, B, P, Q, we don't know what P and Q are, C, -2, -8, and D is -4, -3. They also tell us that BC intersects the x-axis at that point F. And they tell us that angle DCB, so this angle here, is equal to alpha. Right. Let's look at the questions. Firstly, they want us to calculate the gradient of AD. Now from grade 9, in order to calculate the gradient of a line, there's a formula. Gradient is equal to the change in the y values. So let's go YA minus y of D all over the change in the x values. So it's x of A minus x of point D, and then it's just a matter of substitution. So let's go back to see what our points are. Point A is 1, 7. All right, so the y of point A is 7. There's the y value. Okay, and the y of point D is -3. So it's going to be 7 minus -3. Let's go back to the x value of the x coordinate of point A is 1, and that of D is -4. So it's going to be divided by 1 minus -4. Okay, allow me to continue on this side. If you simplify that, that becomes 7 plus 3, which is 10. Oops, 7 plus 3, which is 10, I beg your pardon. And we're dividing that by 1 plus 4, which is 5. Therefore, the gradient of line AD is simply equal to 2. Moving right along. Determine the equation of BC in the form y is equal to mx plus c. Right. Where is BC? It's that line there. Now, we're told that AD is parallel to BC. Now, if we're working out the equation of a straight line, we need to worry ourselves about two things. We need to worry ourselves about the M and the C. Okay, so we know that the two lines are parallel. We know that BC is parallel to AD. Therefore, they have the same gradients. Remember that, folks. Parallel lines have the same gradients. Gradients are equal to each other. So we're halfway there. We know that the m value of the equation of BC is simply equal to 2. So I can already write y is equal to 2x plus c. I now need to worry myself about the value of c. Okay, where am I going to get this value of c? Right, if I've got a value of x and a value of y, then I can substitute those two into this equation and solve for the unknown c. Okay, so all I need is a point that lies on BC. And if you look, point C lies on BC, and the coordinates of point C are -2, -8. So we're going to substitute that point. So let's substitute -2, -8 into this equation and solve for C. So that means that -8 is equal to 2 multiplied by -2 plus C, right? So that on the right-hand side will give me -4. So it means that my C will be equal to -8 plus 4, right? Therefore, my C is equal to -4. So I've got my C value. I can put it all back together now to give the equation of BC. We can conclude that y is equal to 2x minus 4. Question 1.2 answered. Right, let's move on to the next question. Still based on the same sketch. They say now determine the coordinates of point F. Point F is that line there. Ask yourself, what is happening at point F? What is special about point F? At point F, that is where the line BC intersects or cuts the x-axis. So how do we work out the x-intercept of a line? We simply let y equal to 0, because all points on the x-axis have a y coordinate of 0. So we know the formula of BC. Remember we said it is y is equal to 4x, I beg your pardon, 2x minus 4. All right. In order to work out the x-intercept of a line, what do? From grade 9, the dual intercept method, we say let y equal to 0. So that means I go back to my equation where I see a y, I simply replace it with a 0. So that means that 0 is equal to 2x minus 4. There's an easy linear equation solving for x. Take the 4 over. 4 is equal to 2x. Divide both sides by 2 will give me x is equal to 4 divided by 2 is 2. Right. So I know that the x value, the x coordinate of point F is 2. That means that the coordinates of F are simply equal to 2, 0, because it's on the x-axis. All right, so to answer the question, the coordinates of F have to be equal to 2, 0. Right, so that's 1.3 answered. Okay, let's move on to the next question. Right, let me just put a 2 there. It helps folks to, once you've worked out answers, write those things on your sketch, on your exam paper, because it's your exam paper, so you can scribble on it. That will help you work out the answers to the following questions. All right, so we now need to show that this angle here, this alpha, is equal to 48.37 degrees. Right. You need to remember that tan, there's a rule that says tan of a particular angle will be equal to the gradient. Okay, let's go through this rule. This alpha, or this angle, is the angle that a particular line makes with the x-axis. All right? So, tan of the angle that a line makes with the x-axis is going to give me the gradient of a particular line. Right, so we need to work out that angle alpha there. However, we've got a slight problem. That angle is not an angle that a particular line makes with the x-axis. All right, so I might have to calculate other things in order to eventually get to my answer. All right, so if I'm going to draw a little x-axis there, horizontal line, you're allowed to do this on your question paper, all right? If I can work out this angle here, I'm going to call it angle theta, all right? And if then I can work out this big angle there, let's call it angle beta, right? So if I can work out angle theta and beta, I can work out angle alpha, because angle alpha is the difference between this big angle and that small angle. Okay, I'll say that again. If I take this big angle beta and I subtract that small angle alpha, I'll be left, sorry, if I take the big angle beta, subtract the small angle theta, you'll be left with alpha. Right, so let's try and work out theta first, that small angle. Okay, so I need to know the gradient of line BC. All right, so we worked out the gradient of line BC previously, and let's just go back to see what it was. Okay, sorry, it's not on that page. We need the gradient of line BC. There we are. Gradient of line BC was equal to 2. Okay, let's go back to answering the question. Right. So the rule says that tan of a particular angle, we called it theta in this case, is equal to the gradient of the line in question, which is 2. All right? We're using BC here. Let me just make a note there. We're using line BC. Right. So we all know that in order to work out the angle, if you're given the ratio, we're going to go theta is equal to of 2, right? So let's do that on our calculators. Okay, let's clear that. So we need shift tan of 2, close bracket. And we get an answer of 63,43 degrees if you round it off to 2 decimal places. So it means that my theta is equal to 63,43 degrees. Right, so we've got that guy. Okay, let me just write it in there. 63,43. Right, well, let's see if we can work out alpha now. Sorry, not alpha, beta, the big angle. Right, so we now need to worry ourselves. We can't use BC anymore because that helped us with theta. So a line that will help us work out angle beta is the line CD, right? So if I can know the gradient of this line, I can work out angle beta, right? So we need to work out the gradient of CD first, right? So the gradient of CD is a change in the y values over the change in the x values. So let's go -8 minus -3, so it's -8. I'll make it a +3 because it's minus negative, minus is a plus, over, let's do a change in the x values. -2 minus -4, so it's -2 plus 4. Right, so if you simplify that, -8 plus 3 will be -5. Divided by, what is -2 plus 4? That is +2. So that is -5 over 2. Right. We're getting closer. Okay, so tan then of angle beta is equal to -5 over 2. So in order to work out beta, we take the inverse. 5 over 2. Sorry, it's a negative. Right, let's bring up our calculator. Let's clear that. So we go tan. No, sorry, I want shift tan. Shift tan, right? And we've got a -5 over 2. Okay, let's close that. and we get an answer of 68, oops, come back, okay, 68, if you round it off to 2 decimal places, 68.20. Okay, so our beta will be equal to 68.20. We're going to ignore the sign, okay, because 10 is negative in that quadrant, okay, but that is an acute angle, okay, so that actually gives me this angle here, this one here, that's 68.20, but I don't want that. I want beta. So in order to work that out, these are angles on a straight line. I need to go 180 minus 68.2. So I beg your pardon, that is not beta. So beta will be equal to 180 minus 68.20 degrees. And let's bring up our calculator. Let's clear that. 180 minus 68.2 degrees equals, it is equal to 111.8 degrees, okay? So so let me just erase that. That is not true. However, angle beta is equal to 111.8. So this here is 111.8. So now in order to work out alpha finally, we can take this big angle, this is 111.8, and subtract 63.43. Okay, so allow me to write that here. So therefore beta is equal to 111.8 degrees, take away 63.43 degrees, and if we still on our calculator, so let's just minus 63.43. And if you get that as a decimal, it's 48.37, which is what we had to prove. Okay, so therefore our angle is equal to 48.37 degrees. And again, this is not beta. This is actually equal to alpha. All right, so basically what we did, we calculated the big angle, which was 111.8. From that, we subtracted the small angle theta, which was 63.43, and we got an answer of 48.37. Okay, moving right along to the next question. Another question I taken from the November 2013 paper, paper 2, question 5. In the diagram below, P is a point minus 50. So where is point P? There it is. And the inclination, again, that is the acute angle that a line makes with the x-axis. The inclination of line PT is 63.43. There it is given. S is the midpoint of S is the midpoint and the y-intercept of PT. So this point here cuts PT in half, and it is also the y-intercept of the line PT, as you can see. And they say R is a point on the x-axis such that PO, the ratio of PO to OR is equal to 2 to 3. PO to OR is equal to 2 to 3. Awesome. Let's answer these questions now. 2.1.1. We need to determine the gradient of PT correct to the nearest integer value. So we need to round off our answer. Gradient of PT. There is PT there. Okay, we're not given 2 points, so we cannot use change in y over change in x this time. However, we're given the inclination, so we have to go back and use this rule. That tan of an angle, I'm going to call it 63.43, is equal to the gradient of that line. All right, so let's bring up our calculator. Clear. tan of 63.43 gives us an answer of 1.995. So if you round it off to the nearest integer, you're going to get an answer of 2. Okay. So it means that my gradient of the line is approximately equal to 2. And folks, this is not 63.43, but 64. Right, so 64.43. Okay, and let's just check our answer. Tan of 64.43. And it's just above 2. So if you round it off to the nearest integer, it's still 2. So that's fine. Right. So that's a gradient of PT. Now they say the distance PS in third form. Right, where's PS? There's PS. So we need to know how long it is from that point to that point. Okay. So in order to work out how long it is from that point to that point, we need to know what the coordinates of S are. Because if you look at triangle SOP, you can see that it's actually a right-angled triangle. And since it's a right-angled triangle, if I know how long that is, PO, it's actually equal to 5. And if I know how long OS is, I can then work out PS using the theorem of Pythagoras. So we need to concern ourselves now with working out what S is, the coordinates of S. Right, what's happening at S? At S, the line PT intersects the y-axis. So we need to work out the y-intercept of PT. But in order to do that, you need to have the formula for PT. Okay, we already have the gradient. We know that in order to, the formula of PT will definitely be y is equal to 2x plus something, which is the y-intercept. Okay, so in order to work that out, we can simply just substitute any point that lies on the line PT, and we are given minus 5, 0. So let's substitute minus 5, 0. So if you subst minus 5, 0, we will have 0 is equal to 2 multiplied by negative 5 plus c. And that's a linear equation. If you want to solve for c, you take that over to the left-hand side, so you'll end up with 10. So it means that my y-intercept is actually equal to 10. So let's go back to our sketch. We know that this point here is 0, 10. Okay? So we're now in a position to work out the length of PS using Pythagoras, because this is 5 units, this is 10 units. Okay? So Pythagoras says PS, which is the hypotenuse, so PS squared will give me 5 squared plus 10 squared. So PS squared will give us 25 plus 100 is 125. Now they want it in third form. The calculators we use today can give that to us easily, but if you don't have a calculator, then you can just prime factorize 125, because then PS will be equal to the square root of 125. So if you prime factorize that, you can do a little ladder here. Okay, if you divide that by 5, you'll get 25. Divide that by 5, you'll get 5. Divide that by 5, you'll get 1. So it means that PS is equal to the square root of 5 squared times 5. All right? And so it means that PS in simplest third form will be equal to 5 square root 5. If you can't do that, your calculator can do that for you. So square root of 125, there, in simplest third form. Right. Okay, moving right along. Still question 2, they want us to work out the coordinates now of R, that point there. Okay, so we know that that is 10. Okay, but we told something about point R. The only thing we told about point R is that the ratio of PO to OR is 2 to 3. So that line divided by that line will give me 2 over 3. PO, the length of PO, divided by the length of OR will give me 2 over 3. Right. So we now need to work out the coordinates of R. Okay, I know what PO is. PO is equal to 5. I need to work out how long R is. Sorry, the coordinates of R in order for us to work out this ratio. Okay, so PO is 5 units. OR is what we need to work out. We know that that gives me 2 over 3. Right? So if I cross multiply, we'll have 2 times OR is equal to 5 times 3, which is 15. Right? I'm just cross multiplying there. Divide that by 2, divide that by 2. It means that OR is actually equal to 15 over 2 units long. Okay, so it means that, let me just get rid of that. It means that the coordinates of R are 15 over 2 and 0. There we've answered the question. Okay, so therefore R is the point 15 over 2 and 0. Okay, moving on. Question 2.3, we need to calculate the area now of this triangle PTR. Okay, let me just quickly write down what we know. Okay, we know that that is 10, but that's not going to help me much. Okay, how do we work out the area of a triangle? The formula to work out the area of a triangle is half times base times the perpendicular height. Okay, so if I take my base to be PR, so that's 15 over 2, 0. If I take that to my base, okay, I'll now need to multiply that by a perpendicular height. Let me draw in a perpendicular height. Okay, so I need to know how long this line is. I'm going to call this Q. Okay, I need to know how long TQ is, but the only way I can know that is if I know the coordinates of T. And that brings us to the end of question 2, and it brings us to the end of the first session of this exam revision. So we're going to take a quick ad break. See you in a few minutes. Welcome back, folks. Let's continue with our revision of analytical geometry for grade 12s. Here's the next question. It says, in the diagram below, M is the center of the circle having that equation. And they say the circle passes through the point R, which is 0 minus 4, and the point N, which has coordinates PQ. They also tell us that angle RMN is 90 degrees. There it is indicated with a little square. Then they say the tangents drawn to the circle at R and N meet at P. Okay, right, so what do they want us to do? They say, show that M is the point 3, negative 1. Right, so the only thing we know about M is that it is the center of the circle with that equation. So we need to show that, we need to find what the coordinates of M, in other words. Right, so if we take our equation is x squared plus y squared, okay, let's go up to see the rest, minus 6x plus 2y and minus 8. It is equal to 0. Right. You've been taught how to work out the equation of a circle using the general formula. Remember, the general formula for a circle whose center is not at the origin will be x minus a point, let's call it a, all squared, plus y minus a point, I'll call it b, all squared. Okay, and that will give me the square of the radius. So if we can change this equation here into this general form, we'll then be able to work out the center, because the center will be represented by those two values. All right, so let's calculate that. So we need to complete the square. So our formula is x squared. I'm just going to change the ordering a bit. So it's x squared minus 6x, this is our equation, plus y squared plus 2y. Remember, if you complete the square, we can already just get the constants over to the right-hand side of the equation. Right, so if you complete the square, we take those two values, those two terms, we now take half of that middle term and we square it. Okay, so half of 6 is 3, and if you square that, it's 9, so that is what we need to add. Okay, let's just use a different color for the stuff that we're adding. Okay, so it's going to be plus 9. Right, let's go back to our orange. And if you look at the y's, okay, we take half of 2, which is 1, and if you square 1, you get 1 again. So we're going to add 1. Right, but now this is an equation, so whatever we did to the left-hand side, we have to do to the right-hand side as well. So on the right-hand side, we're going to have 8, but then we still need to add the 9, and we still need to add the 1, so that our equation balances. So if we now factorize those three terms, we're going to get a binomial squared. So it's x minus 3 all squared. Okay? And if we take those three terms, that trinomial, and we factorize it, we're going to get y plus 1 all squared. Okay, you can always check that. Just take the trinomial, factorize it, get the two brackets. You'll realize that the two brackets are exactly the same. All right? And what is on the right-hand side? We're left with 18 if you add those three. Now, if we look at what we have here, we can see that the value of A is equal to negative 3. All right? So it's equal to positive 3. Okay, because that minus is that one there. Okay, and we can see that the value of B there is actually equal to negative 1, because a negative times a negative will give me a positive. So this implies that the coordinates of M, which is the center, are actually equal to positive 3 and negative 1. Okay, and we've answered the question. Moving right along. Next question. So this, let me just write the coordinates of point M here. It's 3, negative 1. Right, what do they want us to do now? Determine the equation of MR in the form y is equal to mx plus c. MR is a radius from the center to the point R. In order to work out the the equation of a line, we need to work out an M value and a C value. So the M of MR is the change in y values, which will be negative 1 minus negative 4. So it's negative 1 plus 4, divided by the change in the x values, which is 3 minus 0, which is just going to be 3. So it means that the gradient of MR will be 3 over 3, which is equal to 1. Right, we now need to work out the C. Okay, we already know that y is equal to x, because it's 1x, that's a gradient, plus c. So if I can find a x and a y, so a point, the coordinates of a point, and substitute those into this equation, I can then have a linear equation and solve for c. So what point can we substitute? We can substitute 3, negative 1. That's fine. Okay, so negative 1 is equal to 3 plus c. So it means that my c is equal to negative 1 minus 3, which is negative 4. Right, so therefore, the equation is y is equal to x minus 4. That's the equation of line MR. Moving right along. We now need to show that Q is equal to 2 minus P. So we need to worry ourselves about point N now. let me just write the coordinates of m again. 3, -1. It helps to write these things down so you don't forget, because we need them to work out the next question. Right. We see that that little square means that MR is perpendicular to MN, right? So it brings us to the relationship of gradients of perpendicular lines. I know the gradient of MR. We calculated it to be equal to 1. So in order to work out the gradient of MN, remember the gradient of MN, we need to tip the gradient of MR and then change the sign. So if you take 1 and tip it, you still get 1. But if you change the sign, you're going to get -1, right? So it means that the gradient of MN is going to be -1, all right? So we now need to work out the gradient of MN in terms of P and Q, because as you can see, the P and Q have not disappeared, they're still there, right? So therefore the gradient of MN will be the change in the Y values. So that's going to be Q minus -1, which is Q plus 1, divided by the change in the X values, which is P minus 3, divided by P minus 3, and that will give me -1. So if you solve for Q now, because that's the subject of the formula, we're going to multiply both sides by P minus 3. So Q plus 1 is equal to -1 multiplied by P minus 3. So Q plus 1 is equal to -P plus 3, right? If you take that 1 over, we're going to end up with 3 minus 1, which is 2 minus P, which is what they want us to do. So we've answered the question. Moving right along. Now they say determine the values of P and Q. Okay, remember this is 3, -1. Okay, we need to work out the values now of P and Q. And we know that Q is 2 minus P. So Q is equal to 2 minus P. Right, if you look at line MN, this line here, and that line there, and based on the fact that M is the center of that circle, it means that those two lines are the radii of that circle. And we all know that the radii of a circle are all equal. Okay, so now this is where the distance formula comes into play. Okay, so how would you express the distance of line MR? Distance formula says you take the square root. Okay, so you subtract the X values, so that'll be 3 minus 0 all squared, and you add that to the difference in the Y values. So it's going to be -1 minus -4, so I'm going to make that a +4. And you square it, okay? So that line is equal to MN. So we need to express MN now in terms using the distance formula. So again, we need a big square root sign. The difference in the X values will be P minus 3 all squared. And we're adding that to the difference in the Y values, which will be Q minus -1. So that's Q plus 1 all squared. Okay, but now this equation has two unknowns, which is not going to help me. However, I can express Q in terms of P. Instead of Q, I can write 2 minus P, and that'll leave me with one unknown, which is P, and then I can solve the equation. So let's go back to our Q. Wherever I see a Q, I'm going to substitute 2 minus P. Right, so let's simplify the left-hand side. Okay, so that's 3 minus 0 squared is 9, plus -1 plus 4 is 3, all squared is another 9, so that's square root of 18. Right, so we're going to go here, and where I see a Q, I will write 2 minus P, so we can leave that as P minus 3. Okay, instead of a Q, I will write 2 minus P plus 1, all squared. Where is that coming from? So this, I've replaced that Q with that 2 minus P. which we proved in a previous question. Right, so let's continue. If you simplify that, that's just square root of 18. And if you simplify that right-hand side, if I FOIL that bracket, it's p squared minus 6p plus 9, okay, plus adding like terms in the bracket, 2 plus 1 is 3. So I'm going to write that as 3 minus p for now, and I'll simplify it in the next step. So square root of 18 is p squared minus 6p plus 9 minus 6p plus p squared. Okay, just need to add like terms now. Okay, it's going to be 2p squared, that's those two, and minus, sorry, that's p squared, minus 12p plus 18. All right? I'm solving for p, so I can already square both sides to get rid of the root sign. So it means that 18 is equal to that, 2p squared minus 12p plus 18. Okay, it's a quadratic equation. I need to solve for p, so let's make it equal to 0. Okay, so 18 minus 18 is 0, so I'm just left with 2p squared minus 12p there. Okay, it's a quadratic equation. I need to first factorize and then, factorize and then solve for p. Highest common factor is 2p. I'm left with p minus 6. Okay, I've got a product of two things. I'm getting an answer of 0, so it means that 2p is equal to 0, or p minus 6 is equal to 0. That means that p is either equal to 0 or p is equal to 6. Now, which one are we going to go for? Let's go back to our sketch. Is p going to be equal to 0 or 6? If you look at our sketch, p is in this quadrant here. And in this quadrant, all x values are positive. And if p was equal to 0, then it means that it would be on the y-axis. So we're going to have to go with p is equal to 6. P is not equal to 0. Right, so if I know that p is equal to 0, I can therefore work out what q is equal to. I know that q is equal to 2 minus p. Let's go back and just double check that. Yes, q is equal to 2 minus p. So it means that q is equal to 2 minus 6, which is negative 4. Right, so we can say the coordinates of p and q are 2, so p is equal to 6, I beg your pardon, and q is equal to negative 4. Right, moving right along. Okay, so they say determine the equation of the circle having center 0, so having center O and passing through N. Right, so we know the coordinates of N now. We said that P is equal to 6, and we said that our Q is minus 4. Okay, so if I want a circle, or the equation of a circle going through that point, with a center at O, I know that the general formula for a circle with a center at the origin is x squared plus y squared is r squared. Okay, and if you substitute values for x, so the x is going to be 6, so it's 6 squared plus my y, because that's the value of q. Simplifying that, that's 36 plus 16 is equal to r squared. If you add those two, it will give you 52 is equal to r squared. So therefore, the equation of the circle will be x squared plus y squared is equal to 52. Let's end it there for now, folks. Let's take a quick ad break and we'll continue shortly. Welcome back, guys. Let us move on to the next question. We're told that circles C1 and C2 in the figure below have the same center M. Okay, and so that's my center there. And they say that P is a point on C2. So it means that if I were to draw a circle a bigger circle, P would lie on that circle. So if I draw just in rough, right? And then they say PM intersects C1 at D. So there's my line PM. It cuts C1 at point D. Right? So if I draw a circle C1, okay, that point D there is where the line PM intersects it. The tangent to DB, so the tangent DB to C1 intersects C2 at B. Okay, so if that's my point B there, the tangent to C1 will go through B. And the equation of the circle C1 is given by that equation there. And the equation of line PM is y is equal to x minus 2. Fine, so that's all we're told. What do they want us to do? Find the coordinates of center M. Okay, center M is the center of the two circles, but we're given the formula or the equation of C1. So that's that. Okay, so if you want to find the coordinates of M, we need to complete the square. Right, so to answer 4.1.1, okay, let's use a different color. We know that the equation is x squared plus 2x plus y squared plus 6y plus 2. Y squared plus 6y plus 2. And that is equal to 0. So if I complete the square there, I'll get the coordinates of my midpoint. So if I take the two x values, so this is 2x, okay, so it's x squared plus 2x. If I complete the square there, I'm left with that. And if I complete the square using the y variables, I'm going to add a 9. So we take the 2 over to the other side, but because I added 1 here and 9 there, I must add the 1 and 9 on the other side as well. So it's plus 1 plus 9. Right, so if you factorize now the first three terms there, you're going to get x plus 1 all squared. Factorize the next three terms with the y variables, you're going to get y plus 3 all squared. Add the like terms on the right-hand side, that's going to be 10 minus 2, which is 8. Right, so therefore the coordinates of M, which is the center, are going to be -1, -3. So I can go back to my sketch and write -1, -3, which makes sense. So that is -1, -3. So that is that point there. Right, 4.1.2, they want the radius of circle C1. We can get that easily from the equation, because we know that the equation of a circle is going to be something squared plus something squared is equal to the radius squared. So it means that the radius squared is equal to 8, which implies that the radius is therefore equal to the square root of 8, and that is the radius of circle C1. Let's move right along. Next question. Determine the coordinates of D, the point where the line MP and circle C1 intersect. So the coordinates of D, I'm worrying myself about that point, and it is a point where the line MP, which we were given the equation of, y is equal to x minus 2. Let's double check that. Yes, it's y is equal to x minus 2. And so it's a point where the line MP and the circle C1 meet. We've got the equation for C1, and we've got the equation of the line MP. So if we make those two equal to each other, we can find out the points, the coordinates where they meet. We know that y is equal to x minus 2. And the equation of my circle, let's just go back to the previous page to get it, was x plus 1 all squared, y plus 3 is equal to 8. Awesome. So it's x plus 1 all squared plus y plus 3 all squared is equal to 8. Those are our two equations. Right, so all we can do, what we need to do now, to substitute equation 1 into equation 2, an easy simultaneous equation sum. So let's go. Where I see a y, I'm going to replace it with x minus 2. So that'll be x plus 1 all squared plus x minus 2. Where is that coming from now? It's coming from this equation there, plus 3 all squared is equal to 8. I've got an equation now and I can solve for x. So let's simplify that. X plus 1 all squared plus, add like terms, it's x plus 1 all squared is equal to 8. These two look like each other, so I can say that is 2 x plus 1 all squared minus 8 is equal to 0. It's a quadratic equation, so I need to make it equal to 0 and then factorize. Okay, so if you want to factorize that now, what we can do is take out a highest common factor of 2. So I'm left with x plus 1 all squared minus 4 is equal to 0. Divide both sides by 2. The 2 falls away, so I'm just left with x plus 1 all squared minus 4 is equal to 0. That's a lovely difference of squares question. So it means that x plus 1 plus 4 and x plus 1 minus 4 will be equal to 0. Adding like terms in the first bracket, that's x plus 5. And in the second bracket will give me x minus 3 is equal to 0. So that means that x is either equal to negative 5 or x is equal to 3. So that is the x coordinates. Those are the two possible x coordinates of my point D. So which one shall we go for? Will we go with x minus 5? Sorry, will we go with minus 5 or positive 3? Let's look at where D is situated. It is situated there. So it definitely cannot be positive 3. Okay, so this must be minus 5. It must be the first answer. So that is not right. Okay, so we're going to go with minus 5. Right, in order to get y now, we can substitute that x is equal to negative 5 into any of the equations. So let's go with the easiest one to do. So if I substitute x minus 5 into here, I'm going to have y is equal to minus 5 minus 2, which is minus 7. That gives us the coordinates of point D. D has the coordinates negative 5 and negative 7. And that brings us to the end of this session on exam revision on analytical geometry. So from me, thank you very much for watching and all the best for your exams.